Welcome everyone to this HTTPS series by Simplify Bytes. Today we'll discuss about TLS and SSL certificates. Let's see a typical server without a certificate. Client sends a hello message. In return, server sends its public key. While sending its public key, an attacker intercepts the message and sends his public key instead. Now there is no way the browser can verify that this public key belongs to the internet server. This type of attack is known as man-in-the-middle attack. This problem is addressed using the digital certificates. Let's see what happens in the HTTPS handshake. Client sends a hello message. Server in its response sends the certificate which includes its public key and the signature. Now client can verify that it is from the internet server using its CA certificate. Basically, certificate verifies the authenticity of the server and prevents the man-in-the-middle attack. How does the certificate looks like? An X509 certificate has a subject, the issuer, validity period, the server's public key, and the SHA fingerprint, and the other elements. The most important thing that we have is the signature algorithm and the signature value that will be used by the client to verify the authenticity of the certificate. Now TLS server will generate the CSR and the private key. CSR is certificate signing request which has the public key and the signature of the certificate, and signature is calculated using the hash of the CSR and it is encrypted using the private key of the server. Now this particular CSR will be shared to the certificate authority. Certificate authority will decrypt it using the public key which is present in the CSR to verify if the server actually owns the private key. Now CSR will generate its own pair of public and private key, compute the hash of the certificate using the SHA, and encrypt it using the private key, which is basically known as signing of the certificate by the certificate authority. Now this particular signed certificate will be shared to all these clients CS store. Now this particular certificate will be used by the server and it will be sent to the client to prove his authenticity. Now the moment he using during the TLS HTTPS server hello handshake. The server sends the server hello packet. The client will go ahead, or the browser will go ahead and browse the CS store to get the public key from the CS store of that particular certificate. It will decrypt the signature after getting the public key, and it will obtain the SHA, and it will compare with the SHA of the certificate to verify the authenticity of the server. This is how exactly the whole verification and the generation process of the certificate happens.
Here is one of the website. If you open google.com, so you go here and you can see this. So this is the certificate which you can see. So it shows you it is assigned by GTS, the validity period, the fingerprints. So if you see, here are different levels of certificates that we have. So each level has its own signature which will be decrypted using the public key that is available in the browser's internal CS store. So important stuff here is this SHA and this is number everything. So this is the algorithm is here and the value.
So let me show you where the CS store is located, internal browsers in Firefox. So if you go here in settings and if you go to privacy and security, browse here, you will find
View certificates. So here are the listed certificates that are pre-installed in the browser. You see here it has the information view if you want to see those certificates. So it has the public key, what encryption it has been used, and everything.
So now we'll generate our own self-signed certificate. So first we'll generate the private key. Check here. So we have the private key. Now we'll generate the CSR, the certificate signing request. This is the command that we'll be using. So we'll give the country code and then give some state name. This is how we create the self-signed certificate. yeah, this is, so we have the certificate signing request generated. So this is how the certificate signing request looks like. So it has all the information, subject, address, and we have this public key algorithm as well, what you're using, then the signature it is using SHA-256 policy encryption. Yeah, so if you see here, so generated a certificate. So if you want to view this certificate, you can view this. And so this is the certificate, which is self-signed. The self-signed certificate is the same as a unencrypted connection. So any server with a self-signed certificate is actually prone to man-in-the-middle attack. So what's next in HTTPS series? We're discussing the HTTPS handshake finally. Thanks for watching this video and subscribe to my channel.